All right, so welcome to this week's challenge. We're going to be looking at growth in linear functions. So in your notebook, I would like for you to go ahead and write down your page number and your title, which is Seeing Growth in Linear Patterns. Pause the video while you do that, and then when you're finished, go back to the video. So we're going to be examining a tile pattern in this very first step. So on Dream See Do, there's this pattern I give you that starts with a figure 1 and then goes on to figure 2 and then goes on to figure 3. So if you notice, there's a little bit of a change every time from figure 1 to figure 2, then from figure 2 to figure 3. So I want you to just look at this pattern, and after you've looked at it, thought about it, go ahead and write down what you notice. If you have a partner with you, if you have a classmate with you in class right now, I would like for you to discuss what you see with another student. But if there's nobody, you're working on this on your own, just go ahead and write down, what do you notice about pattern A? So in your notebook, we're looking at pattern A. Go ahead and answer, what do you notice about pattern A? Pause the video while you do that, and then when you're finished, you can go back to the video. Okay, so hopefully you wrote down some thoughts. I would like for you to go ahead and go and sketch the fourth figure. So you see you're given figure 1, figure 2, and figure 3. I want you to predict what figure 4 will look like. To help you with this, you can go to the student tool that is provided here. So it says you may want to explore using this tool. You can click on it. There's a website. And it actually has the figures right there. You see the figure 1, 2, 3. And you can try to make your own. So for example, you can drag this square tile and you can say, okay, well, I want it to look like this. I'm turning it green. I know there's one, for all the figures, there seem to be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So maybe you start doing that. Well, I know I'm going to start out with 6 right here on the bottom, right? So it's up to you. You can either draw, if you don't want to use this, that's fine, but it might be helpful. I would like for you to try and predict what you think the fourth figure is going to look like. When you're finished with that, I want you to draw this in your notebook. So you can use this tool, figure out what figure 4 is going to look like, and then sketch it in your notebook. So sketch figure 4 in your notebook. So pause the video while you do that, and then when you're finished, keep the video playing. So now that you finished sketching figure 4, I want you to start thinking about figure 0. So you see we start with figure number 1, right? There's this pattern already. But I want you to think about, what did it look like before figure 1? So what was the original figure 0? So it's okay if you're not totally sure, but again, you can use this tool, start making it. Well, maybe you think it's just one square. That's what figure 0 is. I don't know. But it's up to you to use the pattern that's here to see if you can draw figure 0. So go ahead, work on this, pause the video here, and sketch figure 0 in your notebook. Okay? When you're finished, so pause the video here. When you're finished, you can go ahead and keep the video playing. Okay, so now that you hopefully have figure 4 and figure 0, I want you to answer this question. These questions. By how much is pattern A growing? Where are the tiles being added with each new figure? Then I want you to color in the new tiles in each figure with a marker or a colored pencil, or you can sketch, you could shade it in with your pencil. But go ahead and on your notebook. I want you to just write down how much is pattern A growing by. So as you can see, this figure 1 starts out with 1, 2, 3, 4, 5, 6, 7 tiles. Then it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it went from 7 to 10. So how much is that increase? Then you're going to look at figure 2 to figure 3 and figure 3 to figure 4, and you're going to tell me, well, how much is this tile pattern increasing by? Then you're going to shade in all your new tiles. So you see how figure 1, this one isn't in the figure 1. So we can change this into a different color. So that shows it's new. Also, this right here is new. So you can see, right? Figure 1 didn't have this one before. So I want you to do the same in your notebook. I want you to show me which tiles are new every time. So when you're finished with that, so pause the video here, work on that, and then when you're finished, you can keep the video playing. Okay, so now you're going to describe to me what you think figure 100 would look like for pattern A. Obviously, I'm not going to make you draw what figure 100 looks like. That's going to be a lot of work. I want you to just predict what you think will happen and then write it down in words. How many tiles do you think would be in the 100th figure? And you need to justify your conclusion. Why do you think that? So for example, you could say, I think there will be 1 billion tiles in figure 100 because based on the pattern I noticed, etc., etc. So you need to come up with some kind of justification. This is just an example. I don't think there are 1 billion tiles in figure 100, but maybe there are. But your job is to tell me what you think figure 100 will look like. So however you're going to figure that out, it's up to you, but write down your reason why, okay? So I'll let you pause the video here and work on that. And then when you're finished, you can go back to the video. Okay, so if we look at figure 0, so hopefully you have a sketch of what you think figure 0 looks like. This is called your starting value. So the number of tiles in figure 0 is your starting value. So let's say, for example, your figure 0 looks like this, what I have right here, then your starting value is 1 because there's just one tile. If your figure 0 look like this, then your starting value is 2 because there are 2 tiles, right? Pretty straightforward. That's your starting value, okay? Now, another term I'd like for you to learn today, besides starting value, is your growth. So let's say your growth is how many you add every time. So let's say we started here at figure 1, we had 3 more tiles. My growth would be 3, okay? So that's the difference between a starting value and your growth. Starting value is just how many tiles you start out with. Growth is by how much you are increasing. So for your 5th question, I would like for you to think about your growth and your starting value for pattern A. So go ahead, write down what you think your growth and your starting value are for pattern A. Pause the video, and then when you're finished, we'll answer the last question. So the last question is just for you to write an equation that relates the figure number X to the number of tiles Y. So this is a little tricky, so I'm going to give you a little bit of help. So first of all, your figure number, right, and the number of actual tiles, we're trying to figure out a relationship between them. So let's just look at figure 1. Figure 1, your input. So here your input is your figure number. Input X is your figure number, right? That's what it says in, yeah. And then your output is the number of tiles. So output for y is the number of tiles. So for example, in figure 1, your input is 1, and your output is 1, 2, 3, 4, 5, 6, 7. So 7 tiles. So input is 1. When your x equals 1, your y equals 7. Okay? Let's look at figure 2. When your figure number is 2, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tiles. So you have 10 tiles. So when x equals 2, y equals 10. So we're going to try to come up with an equation that describes this relationship. So whenever you put in 1 for x, you should get 7. When you put in 2, you should get 10. So you can try various methods. Here's an example. Maybe what you do is you take your input and you multiply by 7, because then I would get 1 times 7 actually, let me do this as an input. Maybe I do input times 7. So this is dot means multiplication, just so you know. So then I'm going to try it with 1 times 7. And 1 times 7 is 7. So this is correct. But remember, this has to work for all your inputs and outputs. So let's try it with my input being 2. So let's say 2 times 7. 2 times 7 equals 14. Well, I was supposed to get 10, so this is not correct. Okay, so my hypothesis that I have to do input times 7 to get the output is incorrect, right? It doesn't work. So your job is to figure out a function, an equation that relates your input and your output. You have to do something to your input that will give you your output, and it has to work for all of the figures. So this might be a challenge. You might need to take some time. You might need to ask me for help. That's okay. But try it. Write out your work, write out your thoughts, and then when you're finished with all 6 questions, you're going to take a photo of your answers in your notebook and then upload it on Dreamseed Do.